Right guys, welcome to another Autodesk Inventor video. What we're going to do this time is we're going to have a look at doing some analysis on this product, which is what we covered in the previous video, but we're going to look at changing material, possibly even changing loads and things like that in here. Okay, now we run a test on this previously, and if you've not got a copy of this file and you want to have a little play around with this, then there's a copy on Canvas, and I'll try and drop a copy of the file into the description of this video. But without further ado, let's get stuck into this, and we'll go along up to the top ribbon bar here. We select the Environments tab. We're going to go into Stress Analysis like we did last time. Now, for those of you that have watched the previous video, you'll actually see that analysis that we did. Yeah, and you might remember the values that we got. I'll run that, and we remember those data, and we logged it on a document, didn't we? Okay, we've got displacement and safety factor as well on that. Now, this time, what we're going to do is we're going to run this analysis again, but we're going to change the materials, and we'll have a little think about what type of materials in when we go into Materials Library. Okay, so I'm going to copy this whole analysis, and I simply do that by selecting the static analysis in the browser, and I right-click. Being a little bit slow. Oops. Right click, copy study, and what that does is it copies everything. Alright, it copies the material I had selected previously, it copies the constraints that I put on, i.e. the bits that I fixed it on, it copies the load that I put on, and we can have a little change of those later, but for this sort of purpose I want to just have a look at changing the material. And I can do that up along the browser on the top, or I can do it on the toolbar on the top, or I can do it in the browser. Either of those, I click on Assign, or I have to click on Material and the right click, but I'll select the Assign one, and what that'll do. So at the moment, this material set is steel mild, or low carbon steel for us Europeans, but I'm going to override that with a different material. And I'm going to choose someone a bit silly. You'll obviously be looking at someone that's a little bit more specific to your needs. And I'm just going to go for lead. Right, it's a bracket for load and stuff on. Lead would never be a material that we'd select, but we're going to run this and we'll see what data we can get. Okay, now at this point it's important to mention that if you've not constrained this object, or you've not put a load on, or you've chosen a stupid material, this software will actually tell you that. Okay, so let's run this simulation and we'll see what information we can get, if any. And we'll do run. Okay, so that's interesting. Alright, so we'll get a little note here that says the deformation is large compared to the model size. And it's telling us what we could do to possibly change that. But I'm going to close that. Now you have a look there, you can actually see I've got a bit of data. This is stress value. I'm going to go back to my Word document. I'm just going to type this up so I don't forget. Now obviously if you've written it down somewhere, you can type this up a little bit later. But I'm going to get that value. What was that again? 526.2 megapascals. We'll get that right in the center there. Getting that there. And we'll go back to our software, and then we'll get our displacement value. Alright, so you can see here why it's told us that displacement's too much, 50 millimeters. That's how much is displaced. And when we swing that around, don't forget this is just a representation, it's the data that's really important. I'm going to go, so we'll go to 50.09 millimeters. I'll just make sure I've got that information right. Yep. And then we'll go back and we'll do safety factor. Alright, and you can see what's happened to our minimum safety factor. It's gone way down. Okay, so we've got 15 in, and then what was it? 0.02 minimum. Alright, now I'm gonna just go into my software. I'm going to take a little picture of this using the snip tool. So for those of us that have never used that before, it's pretty cool. Go start, go snipping tool, and then we'll do a new one, and then we'll take a copy of that, copy it, and we can pop that into our table. A little bit big, so we'll resize it. Alright, so what we're doing here is we're gathering evidence for our portfolio or our file. Alright, so we'll drop that in there. Now we know that's a displacement image, and we know that one was a stress image, but again it's just a bit of evidence to show us that we've actually run these tests ourselves. And then I need to start thinking next is I'm going to go back in and I'm going to copy that study and I'm going to choose a different material now. And at this point I'm going to let you have a little go yourself. Okay. Now we're not just doing this to gather evidence, we're doing this so that we can show that we understand how materials work, and we can back that up by justifying our material choice. So in this section I'm going to be looking for a little bit of a written description of why you think one material is better than the other. Alright, now you might be very surprised by some of the results you get, because you can see here lead's got less stress in it than steel, but it displaces way too much. Alright, so it's not just about getting these pretty pictures and getting some numbers. We actually have to be able to compare and contrast these different materials as engineers. Alright, now I don't want you to worry too much about selecting the same materials as me, and if you do that you get slightly different results. It's not the end of the world, but what we do want to do is we want to get 4 or 5 different materials tested so we can get this data, and then we can start to justify what material might be better than the other. Sort of narrowing down the field of materials, because as you know, there's thousands out there, and it's important that we narrow that field down as much as we can. And what better way to do that than to run some simulations. Okay, so there's plenty to think about there. There's loads of things that we can do in this software, but that's just some of the basics when it comes to material testing. In the next video we might have a little look at changing the thickness of the material and maybe changing the design, moving that web that's holding this bracket together, but that's probably for the next time. Once again, thanks for watching, and if in doubt, give me a shout. Bye bye.